All right. Well, welcome to Make Applications Great Again. And I promise no more Trump jokes. I got that idea from one of the guys on my team. So we're going to talk about OpenShift 3 today. How many people are actually using OpenShift today? A couple of people? Okay. So because this is such a small group, let's just keep it interactive, like ask questions, and we'll just kind of do our own thing, right? Instead of like sticking to slides the whole time to get you guys what you really want out of it. But first thing is you're probably going to notice is, if I escape out of this presentation, what am I running here? Nope. Look at this. Look at that. That's fancy. That's Windows, ladies and gentlemen. I am running Windows. So you're probably wondering why Grant, who is working at Red Hat, who loves Linux, is running Windows. And I just decided to do that this week to show you guys that if this kind of stuff can work on Windows, it can work on anything, right? We have put a lot of thought and effort into making the experience seamless across Windows, Linux, OS X. And this is also my first time using Google Slides, so I'm trying to figure out how to get back into the presentation here. Here it is. Okay, so that's why I am using Windows. Apparently, Red Hat and Microsoft are friends now, which is great. But yeah, I'm a big Linux guy. I've been using Linux for, how old am I? I'm 40, so 22 years, I think I've been using it, something like that. I installed Slackware off of floppies like most other people did. The other thing is in the description, I said that we were going to talk about OpenShift Enterprise, and I have since changed my mind. So you can call me a liar. But what we announced last week was actually OpenShift Online, which is the same code base as OpenShift Enterprise, but it's in the public cloud. It's exactly the same code base, but I am going to be using OpenShift Online, maybe some Enterprise during the talk. And so anyone can sign up for OpenShift 3 online for free. Just go to OpenShift.com or blog.openshift.com, and you can get a link to where you can get access to the developer preview of the new Docker Kubernetes system. So now that you know that I hate Linux and that I like to lie a lot, let me introduce myself because you all hate me now. So I'm actually Grant Shipley. I'm a senior manager on the OpenShift team at Red Hat. I've been at Red Hat a long time, probably like, I guess 11 years, maybe 12 years at this point. I was a principal software engineer for many years and then moved into management. I am on Twitter at gshipley, and all of my source code is on github.com/gshipley, although I've been using GitLab a lot recently, so some of my newer stuff is on GitLab. I also write books. I signed the Learning OpenShift one this morning, so too bad you missed that one. Directly after this talk, I am signing the new O'Reilly OpenShift book that myself and Graham wrote right upstairs if you want to come by and get a free copy of that, and me and Graham will sign it for you. All right. Last marketing slide before we actually get into the talk. I actually started a hackathon. I didn't. OpenShift did. We announced it yesterday. So after this talk, you'll actually know how to use the platform well enough to deploy applications. And so if you're interested, you can sign up for the hackathon. It lasts 3 months. The requirements basically are that you have an app that you deploy to OpenShift 3 that is health related. So it can be anything, running. You can even spin a social beer drinking app as mental health related. It's pretty loosey-goosey on the terms there. So you basically just have to have a running application in a Docker container on OpenShift in the last 3 months. And it's $150,000 in cash and prizes and stuff. All right. So some of you may have seen me talk before, so these first few slides I've actually given before, so bear with me. And how many people went to the keynote this morning? Jim, a big message coming out of that was like the world is changing. So it's kind of coincidental that he talked about it this morning. I know he took my lead, like I whispered in his ear, you know, all these things. But the world is changing, and we've seen this over the last 10, 15 years. This is a picture from 2005. Have you guys seen this picture before? Anyone? Okay, good. New content for people. This is a picture, 2005 in a European city, I assume. And what's interesting about this picture is there's one phone there and one phone down there. And then they're old flip phones, right? I don't even remember what we did with those flip phones. Like, talked on the phones, I guess. Like, no one does that anymore. But I don't know, maybe they were taking a picture or pushing the 2 key 3 times for the letter C. You guys remember that? People used to text me. I'd be like, why are you texting me? If you want to talk to me, call me, right? I'm not texting. And now if someone calls me, I reject the call and say, what are you doing? Text me if you want to talk to me. And so the world has drastically changed. So this next image is the same exact location 8 years later, 2013. This is what society looks like now as we get together. And this was actually the same event. I think it was a viewing of the Pope or something like that. And this joker right in the middle, he even has an iPad. He wants the full experience, right? And so we are going through this huge transformation, and I would argue, and it sounds like Jim agrees with me on this, is that we are actually living through one of the biggest shifts in human history right now, and how fast technology is changing how we interact with each other. But with all of this innovation, we see a lot of disruption. The average lifespan of a U.S. company on the S&P 500, if you're not familiar with the S&P 500, it's an index of the 500 companies that you can track kind of, you know, how the market's going. And that has decreased from 67 years to 15 years, and that's out of a Yale University research paper. So even some of the largest companies that we think of get disrupted fairly quickly now. At the current churn rate, 75% of this S&P 500 will be replaced in the next 11 years. That's pretty crazy. Hopefully, you know, Red Hat is actually listed in the S&P 500, so we need you guys to buy more stuff so we're not one of these 75%, right? So that's your takeaway. But it's kind of amazing that 75% of the top 500 companies are going to be replaced in the next 11 years. And I like nostalgia and history, and the top 5 companies in 1995, no surprises there, right? Walmart, Exxon, GE, GM, and Ford. In 2005, what's changed is that 3 of the top 5 companies are technology companies. It's driving the entire industry across the board. But even software companies can get disrupted. We think of disruption as like a small startup like Uber disrupting the taxi industry, or Netflix disrupting brick and mortar stores. But even software companies get disrupted now, especially, you know, legacy traditional ones. Does anybody know what the top software company in 1995 was? Microsoft? Nope. I'll give you a hint. They don't exist today. Nope. I wish it was Novell. I worked at Novell. Not AOL. They're still around today. In fact, my buddy's a director over at AOL. I have no idea what he does, but yeah, AOL is still around. It was actually Netscape. Netscape actually doesn't exist today. Now, of course, we have the Mozilla Firefox browser and Thunderbird that kind of came out of the Netscape, but Netscape was huge in their server for HTML pages and JavaScript and things like that. So out of all of this disruption, some clarity emerges. What do I hear people saying? I hear people saying that they want to take their traditional legacy enterprise, slow-moving company and make it move fast again, much like we heard in the keynote this morning from Target. That was their challenge, right? They get a lot of processes and they're just too slow, and so they get disrupted again. So they want to move fast again. And, you know, one of the magic silver bullets everyone keeps talking about is containers. But containers are not actually going to solve any of your problems or all of your problems. They're just another tool that you can use to deliver software. And so containers are certainly great, and they provide a lot of efficiency and benefits, but once you start using containers, you realize that you need to start thinking about orchestration once you get them into a production environment. Getting started with, Docker-based containers on your local machine is very easy. You just create a Docker file, run a Docker build, run a Docker run, right? But then when you want to actually move that into a clustered environment with a load balancer and do dynamic DNS and things like that, things get complicated pretty quickly, and that's where orchestration comes in. Excuse me. Now, I get to go out and I get to talk to a lot of people, and so what I see people doing is creating their own orchestration system. And at the end of the day, their container certainly gets where they want it to go, but it's not necessarily the best way to do it, and their data center ends up being much like we experienced with virtual machines at the initial kickoff of virtual machines where we had VM sprawl. People are getting into container sprawl now as they're realizing that orchestration is needed. And eventually their infrastructure is going to reach a tipping point if they are using their own orchestration system, for the most cases. Some people may get it right with do-it-yourself solutions. But what we want to actually do on OpenShift is we work with Google on the Kubernetes project to deliver your containers to your infrastructure in a sane, manageable way so you can have insight into your containers and things are dispersed appropriately across your infrastructure in a sane manner. But that's, we've talked about containers and orchestration, but again, that's only two parts of the puzzle to, take advantage of this stuff. And the last part is actually making that stuff accessible to developers, because we don't want developers creating containers and deploying containers out into production just to let them sit there forever, right? Just to, get old. We experience this with VMs all the time. As a developer, I would get a virtual machine, I'd do something on it, and it'd sit there for 6 months, and the operations team would have no idea if I was using it or not, right? And it's just sitting out there getting old and stale. We want developers to actually create great things with containers and to actually use them, and that's what we're trying to do with OpenShift, and that's what we're going to learn about today. There's actually 3 different versions of OpenShift, and I'll probably use all 3 today in the talk because they are all pretty much exactly the same code-wise. The difference is everything we do is in OpenShift Origin, which is our upstream open source project. That's where all development happens. And in that project is where we pull in the upstream communities like Docker and Kubernetes. We do a lot of work in those communities as well and add some stuff on top of it for developer productivity. And we call that OpenShift Origin. And then OpenShift Enterprise is actually the product we sell, much like RHEL, Red Hat Enterprise Linux. If you want support for it in your data center, that's OpenShift Enterprise. But it's the same code as Origin. And then OpenShift Online is that same code that we actually run for people on the public cloud as a self-service type environment. And so OpenShift was specifically designed for the 2 competing groups inside of IT to actually get together, and that is developers and operations. And who is Darth Vader? Operations or developers? Anyone know? I'm a developer, so it's obviously operations, right? They're the bad guy. The good guy is the developer, Luke Skywalker. But it is a system designed to get these 2 competing groups to work well together. There's a lot of words around that. DevOps is the latest trend, but if you ask 10 people what DevOps is, you get 15 different answers. But that's all we're trying to do is just make a system that both groups can use and be productive with. And you can think of OpenShift in its simplest terms as we're just trying to build a developer experience on top of Docker and Kubernetes that makes it accessible to your normal, everyday, average developer, so they can just work on source code, take advantage of these tools without having to learn all the nuances of both of these systems, which are simple on the surface, but very complex once you get into real-world scenarios. And you can think of Kubernetes as kind of like OpenShift's Linux kernel. With a Linux distribution, you basically have this Linux kernel that is kind of standard among everyone. People work on the Linux kernel, they push patches upstream, and then they add stuff on top of it to make the distribution. That's how you can kind of think of OpenShift as a distribution of Kubernetes, but with a lot of stuff added on top of it to make it nice, right? Like I'm a KDE guy, so maybe KDE Plasma 5.6 or GNOME or whatever the case may be, just adding stuff that runs on top of it. But we fully work inside of the upstream Kubernetes community as well. So we wanted to make sure that if we based a huge platform on top of Docker and Kubernetes, that we had to actually be involved in those upstream communities. And so most of our effort the first year and a half on the platform was just working in the upstream Docker and Kubernetes code bases to get them to where we feel was a place that enterprises could run with some confidence. And so just some quick slides to show you how awesome we are. We are the number 2 committer to both Docker and Kubernetes as far as source code goes. And so what's some of the things that we've actually added into Kubernetes that you may have heard about? Here's a list. More coming. We do work in Kubernetes every day. Quotas and limits, all the stateful stuff. Templates are coming. Lots of cool stuff. All the persistent storage stuff. All right. So what does this look like? Here's, when I was talking about we add stuff on top of Kubernetes, the blue box is Kubernetes. You basically get a namespace. What OpenShift adds on top of it is this concept of a project, which is a conceptualization that developers can use to organize things, right? So developers think in terms of a project, not necessarily a namespace. And so we add that on top of the namespace. We add authentication, users and groups, so teams can work together with the correct authorization to view different projects and what access permissions they have. We added a web console, which we're going to look at, an administrator CLI tool to actually manage the cluster as operations staff, and a developer command line tool. Now, because this is all native Docker and Kubernetes, if you don't want to use any of this stuff, you can use the Kubernetes tools to interact with OpenShift. Like if you're a big kube controller, kubectl command line guy, you can use all of that to work with OpenShift just like you would with a straight Kubernetes cluster. Here's just some more stuff that we've added on top. Source to image up here is something we've added, which is my favorite thing. And that's what we're going to use today. It allows developers to interact with both Docker and Kubernetes with nothing but straight source code from their app. So they don't have to write anything special. So if I have an existing Java app or Node.js app in a Git repo, I can just take that Git repo, pass it to OpenShift, and it actually matches it with a base Docker image for the runtime, builds your application code, builds a new Docker image with your application code and the runtime in it together, and then deploys that to the registry, and then deploys it out to the production systems, and we'll take a look at that. All right, and we add software-defined networking. So this is my opinion. OpenShift is probably the easiest way to install and play with Kubernetes, and I believe that that's right. I was giving this talk at a Kubernetes meetup, and one of the Google engineers was following me to talk about Kubernetes, and when he did a env on his command line, he actually had OpenShift environment variables, and he was like, oh yeah, even I'm using OpenShift to use Kubernetes. That may have changed over the last couple months, but OpenShift is really easy to get up and running. All right, so what you talking about, Willis, to make all of this? That's OpenShift. So here we go. Shut up, I'm done, right? Enough slides, you guys bored to death? I am. All right, let's get out of this. So what we're gonna do is I'm just gonna start using OpenShift. Like I don't really have a script that I'm following. I'm just gonna log in, start doing stuff, explaining what I'm doing, showing you guys how to do it. If at any point in time you have a question, you wanna know how to do something specific, just ask me and I'll show it to you. But I'm gonna start on OpenShift Online. And this is the dashboard. And what's new about OpenShift 3, let me log out here, is we now authorize people with GitHub. right? So you don't even need a RHN, well, that dates me, a Red Hat account to log in. You just log in with your GitHub credentials now for OpenShift Online. So I'm going to log in, and I'm already logged into GitHub, so it didn't have to prompt me. So I don't have a project. So the first thing it wants me to do is create this project. And again, the project is that organizational structure for a developer to organize their things. So we're going to start simple. We're going to create a project. We're going to call this DevNation. And our display name is going to be called DevNation. And I'm just going to say a project. Okay? And I'm going to click Create. And great. Now I have a project. Project is just an empty data structure inside of Kubernetes. The next thing it wants me to do is actually add something to that project. I don't have to do that. I can come back onto the overview, and I can see all my projects here. I can create a new project, I can delete it, or I can go into my project and add something to it. So let's add an application to my project, and I'm going to start with a PHP app, just because that builds fairly quickly, and then we'll do a Java one in a little bit. How many people are developers? How many people are Java developers? How many people are Java developers and hate Java? No one. All right, so we're going to be doing lots of Java today. All right, so I'm going to start with PHP, okay? And so I click on PHP. Ooh, let me go back, because this is important. Oops. Let me make this a little bit bigger. Can you guys see that okay now in the back? So what's interesting is there's these tags, and the tag there says builder. That is a builder image, a builder Docker image. And so that gets into that source to image flow. When I select a builder image, the input required for that builder image is a source code repo. Okay, so it's going to expect me to provide my source code. Now, if I already have a Docker image that I made myself with a Docker build or is on Docker Hub, I can just deploy that, okay? And so if you do already have your own Docker image with your code already up and running, you would not use these builder images, okay? You would just deploy your Docker image to the registry and then deploy it out. And we'll do that in a little bit as well. So I'm going to choose PHP 5.6, which is that builder image. I'm going to give it a name, DevNation PHP, and it's going to ask me for a Git repository URL. So I'm going to pop over to my GitHub account. And this is me wearing the same shirt. Awesome. I have 20 of these shirts. It's the only shirt I have, so I wear the same shirt every day. It's great for doing laundry. All right. So I'm going to go to repositories, and here's a simple PHP app. I'm going to select this. I'm going to get the Git repo URL, and then I'm going to pop back over to my console and paste that in. Okay? So that's all I've done. I've provided a Git repo. Now I used GitHub. You can use any Git repo anywhere you want as long as the OpenShift environment has access to clone from that URL, right? So it can be an internal Git system, GitLab, whatever you want to use, Bitbucket. So if I wanted to, I can do some advanced stuff here, but I'm not going to. I'm going to click on Create. And that's all there is to it. And it's going to say an application has been created for me. Okay, great. So what do we do now? So we go to the overview page, and we can see that a build is running. Okay, so I'm going to look at this build log. And so this opens up, and I can click the follow button here. And we can actually watch the Docker build happening in real time. And so if you're familiar with Docker, how many people have used Docker before? Okay, so what you can think of as happening right now is OpenShift created a Docker file under the covers for you that actually copies your source code in and has a base image or a from tag at the top. It then runs a Docker build on the infrastructure, and it builds that image, and then it pushes it to the registry. And so that's everything that we saw at the top. And the last step is it's pushing that DevNation PHP :latest. It was tagged latest. This is all running in the public cloud, yes, on the online.
All you need is a web browser.
You do. All you need is a web browser, yep. We'll use the CLI and Eclipse a little bit later if we don't run out of time. Now, the one thing I do want to talk about is the first time you do this, it does take a little bit of time. And this is probably going to take about 1 minute and 30 seconds or something like that to do that initial build because it pulled down the base image, which I believe in this case it was Red Hat Enterprise Linux 7.2 or either CentOS 7.2. I'd have to check and see. And then it's going to push this to them. Now, each subsequent build will take about 20 seconds after that. And so we can get into that a little bit later. I can show you as a developer how once you have this deployed, you can bypass all this stuff and actually do true development inside of a container. But let's let this finish pushing before I do. A lot of people do this beforehand, but I actually like doing it in real time so you can see, just how slow this stuff actually is. And it just completed in 1 minute and 59 seconds. And so now it's actually going to deploy this out. So it's creating a pod. And a pod is a Kubernetes concept that you can basically think of a pod as a container. Okay, does anyone know what they mean by pod here? Docker's logo is a well. Is everyone familiar with this? And so Kubernetes uses the term pod to signify a grouping of wells or containers. That's where the name comes from. So now you're Kubernetes geniuses because you know what pod actually means. But generally, you only have one container per pod. Sometimes you can put multiple containers in pod. We don't actually suggest you do that. Let's say if you had an application like a traditional LAMP stack with PHP and MySQL or MongoDB, you wouldn't actually want your database and your PHP code in the same pod because it defeats the purpose. One of the huge benefits of this is being able to scale out independently of one another. So I could scale my PHP code out, but not necessarily have to scale my database. Or if my database is my bottleneck, I could scale that out, but not my front end. Does that make sense? I'm trying to think of a situation where you perhaps would want to have multiple containers in the same pod. Have you guys heard of PHPMyAdmin? It's a web-based MySQL administration tool. Perhaps you may want to embed that in your MySQL database pod so they're together. I don't know. But we suggest you split everything out. Okay, so I have this pod running. And so I built my code from GitHub. So this code right here, it cloned it, which is just a simple index file, and it deployed it out, and it created a URL for me. So if I click on that, this is my application. This is the best application in the world, right? It's just a simple PHP script. But it is out public on the internet. You can hit it in your own browser, and it'll pull up. So that's how quickly I was able to do that. It took 1 minute and 59 seconds, but now I have this application running out there. So the next thing you probably want to do is scale this puppy up, right? So to scale it up, it's very easy. Just click that button. I'll scale to 2 instances. And it'll take a second here. Doo-dee-doo-dee-doo-doo. It normally takes a second. This is going to take 7 seconds. But what's actually happening, and this goes a lot faster normally, but the demo gods are laughing at me right now. The reason that this is much faster than doing the full build is because we already have that image in the registry, so it's just deploying a new container out. And it might be something wrong with this hackathon environment that I'm using.
Does it automatically also load down?
It does, yeah, it does. Okay, so finally, I don't know. This is running on AWS, EC2 East region. I set this up for the hackathon that I was talking about. So it sounds like I have a performance issue that I got to work on now after this talk. But normally that is really fast. So now we have 2 pods running. And if I hit the application again, this is actually load balanced across the 2. If I print the host name or the IP address, they would actually be different if I pulled it up in a different browser. All right, so one of the other things you can do now that we have 2 pods running is look at a topology view of this application by clicking on this button. Now, truth be told, I would never use this. I think this is more just for your manager or something. I don't know, but here it is. Right, this is the big show right here. So let me drag a few things around, and I'll explain what's going on here. This is what our application actually looks like. So this is a route. Okay, if I go back to this overview, this URL is the actual route. Makes sense, right? It's the URL that you use to get into the application. So users come in through that route, which then hits a service, and the service is a Kubernetes object that you can think of as basically a load balancer, okay?
That's at the service end, where traffic comes into the application from the public.
Correct. Yeah, yeah. If you had inter-pod communication, it would not go out that way. It would, okay. So it comes in through the route to the service, and the service you can think of as a load balancer. In the description JSON for the service that we'll look at, it actually has the endpoints in there with the IP addresses of the pods. It then load balances to one of these two pods, the blue things. And these pods are actually defined and backed by two objects. One is called the Replication Controller, which is a Kubernetes object, and then also with a deployment config, which is a OpenShift specific object. And so we'll talk a bit more about those in just a minute. And so the code, yes. Yes, the code I built is actually in a Docker container running in each of those two blue pods, load balanced by the service. Okay? Yep. Correct. So you could actually take that Docker image that we built and run it anywhere you wanted on Docker, right? Yes, the registry, you have access to the Docker registry that we ship with this. Okay? And that's a good question. Like, we firmly believe in no lock-in to vendors, tools, technology, whatever. So if you wanted to stop using OpenShift, that's a fine thing to do. Just take your Docker images out and run them wherever you want, right? Yep. Yep. Okay, so let's go back here and let's look at the Browse tab. I want to show you a few things. We're going to show automated builds real quick. So these are all the things you can look at based on a project. So if I look at a build, I have one build running, and that was my last build. It completed in 1 minute and 59 seconds, and I can look at the build information. We keep all the builds, so at any point in time, you can look at the logs from any build until you decide that you want to delete that build and not have access to it anymore. That way you can roll back to specific versions of the image that was created. So I can look at those logs if I want, but I'm not going to do that because we saw it as it was building. I can look at the configuration, and this has some pretty cool stuff on it. We can see my build strategy as source. Now, we also support the binary build strategy. So if I'm a Java developer and I'm using IntelliJ or Eclipse to build my WAR file, I can deploy the WAR file into this process as well. It does not have to be source code. You can see my GitHub repo and my branch. I use the master branch. You can actually do it from different branches. Now, over on the right side, yeah, you could do that. Yeah, that's one way to do it. Okay, so over on the right, we have these triggers. That's what I want to show you right now. We have generic webhook triggers and GitHub-specific webhook triggers. And what this means is anytime this trigger comes in, it's going to create a new image for OpenShift PHP 5.6. So you can set up all kinds of different triggers. So like, I'm using the Rel 7.2 base image, I assume, for this particular build. If that base image actually changes, meaning that it got some security errata applied to it from Red Hat, I can set this up to where it'll automatically deploy that out to my application, so I don't actually have to do it myself. You can set up a lot of different scenarios there. But what I'm going to do is I'm going to copy this GitHub webhook trigger, and I'm going to go over to my GitHub repo, and I'm going to go to Settings and Webhooks, and I probably already have one. I don't, so I'm going to click on Add Webhook. Let me authenticate here. Wrong password. Okay, so I'm going to paste in that payload URL that I just copied from the OpenShift console. It doesn't actually have a password, and I'm just going to disable this. Maybe we do have. I assume this is a valid SSL cert since this is the official environment, but I'm just going to disable it anyway, just in case. So I'm going to save that. Okay, So now as a developer, what I can do is I'm going to clone this to my local machine here. Let me make a directory called dev. Oh gosh, you guys certainly can't see that. Is that better? And yes, I am running Z Shell on Windows. And I was hitting my YubiKey soft token over here. That's why those numbers are coming up. You guys know what that is? The little USB OAuth thing. All right. So what I'm going to do is I'm going to git clone that repo. And if I go into simple PHP, I have this index file. Oh, my Z shell is messed up. Look at that. All right. And so I'm going to do an echo. I'm going to do some line breaks here. And I'm going to say, welcome to DevNation Automated Builds. And I'm going to save that. And then I'm going to do this. Go to my overview page. Okay. So you can see I have 2 pods running now, and I just made a code change. And so what I want to do as a developer is commit this code. So I'm going to say git commit code change. So that pushed it to my local repository on my laptop. Now I want to push it up to my GitHub repository, okay? So to do that, I'm just going to say git push. And when I do this, look right here, okay? Oh. You can tell I've never used this laptop before. Did I, oh. All right, give me a second here. What's going on here? Yeah, I know, I'm trying to, the permissions on your socket directory are too loose. Other users may be able to read. So let's run this. I probably should have used this laptop beforehand. Ah, you know what? Let's do this. Let me edit it right inside of GitHub. That's always the right thing to do. So I'm just going to edit it right inside of GitHub here until I generate a new SSH certificate. So we're going to do BR welcome to DevNation, okay? So I'm going to commit this, update. Okay, so that was committed, and you can see that OpenShift was identified via that webhook, and it's starting a new build automatically for me. And so as a developer, that's pretty nice because I can just work on my code. When I get ready to commit it, it's going to automatically update in my development environment for me. And this second build normally takes a little bit less time, maybe 30 seconds or so. Any questions so far? Yeah.
Is that going to bring down both instances for the new deployment at the same time?
It's doing it right now.
So, oh, I see. It's creating the new instance while the old one's still active.
Yep. So now that the new one's up to 2 pods, it removes the other pod.
So the build happens based on code change.
Yep.
And the deployment happens immediately after build. What if your process, for deployments is
Different. Yeah. You can do a no automated deploy, and it'll just run the builds, and then you can actually go in. When you're ready to deploy, you can go into Browse Deployments and go to your deployment config and click this deploy button, and it'll run a deployment. Yeah? No. Yeah. It's per project, yes. Well, yes. Yeah. The question may lead to, as an administrator, can I disable that? And that I don't know the answer to. I'd have to find that out. Okay, so that was pretty cool, right? We were able to do that and build this thing out and have it automatically update. And you saw the rolling update there. It deployed the new image, and then scaled down gracefully, and then did it's called a rolling deployment. You guys are familiar with this, right? I don't have to explain it. But you can also do blue-green, whatever type of deployments you want to do. You could also just bring it all down, deploy it, and then bring it back up if that's your process. It's pretty flexible on the things you can do. Okay, so let's look at something else here. If I go into my pods, these are my containers that are running. One of the cool things we can do is actually come in here and get some information about it. I can get the IP address of the node that it's running on. And so this is running in AWS, so it's going to have their TIM private space. And then also the SDN, which is the 172 private space, okay? And the restart policy is always, that's the type of stuff you would change if you don't want to restart. And by that, let me show you what I mean. So the restart policy is set to always. So hang on. Let me get the command to log in on the command line tools. Because remember, with OpenShift 2, we did username password auth. With OpenShift 3, we're using GitHub auth or LDAP auth, whatever you use for your organization. And so because I don't know this user's GitHub ID, I actually have to generate a token or GitHub username password. And so that's how I log in on the command line now, is with that token. So now I'm logged in, okay? And I'm going to show you some command line stuff real quick. I'm going to do OC get pods. And this will show me my 2 build pods that we have. Remember I said we don't delete them. They're not running, like they're just consuming, they're just holding the logs. But we do keep them around forever until you delete them, just in case you want to look at the logs. This is the entire build pod. When we run a build, we actually spin up a pod under the covers to run the build. And then we shut the pod down. We basically scale it to 0, you can kind of think that. So we could start this build again if we wanted. If we wanted to go back to that build, we could actually start it again. It's going to consume a little bit of disk space. That's about it. No memory. Yeah. Yeah, no, the image is not in there, no. And then we have our 2 running pods. Remember, we have 2 right now. So what I want to do is show you kind of a fake failure. And by fake failure, I'm just going to kill one of these pods on the command line. So we have 2 pods running. And so what I'm going to do is I'm going to say OC delete pod. And I'm going to say DevNation. Do I have my tab completion? I don't. Dang it. Oh, I do. Sweet. Okay. So we do have tab completion, even for Windows, which is nice. So I'm just going to randomly kill this pod and watch what happens over on the right. It killed it and spun it right back up. Because it didn't know that I killed it. It just knew that that pod was no longer responding. That container was no longer responding. It could be because, you know, one of the switch is down that particular physical hardware is attached to, or whatever the case may be. Maybe the entire data center went out and you have OpenShift across different data centers. Whatever the reason, some amount of these pods just went down, and OpenShift knew about it almost instantly and then recovered from it, okay? And the way that that works is through this deployment config. This is the object that OpenShift added on top. You can also do it with replication controllers. But if I go look at my deployment, here's my DevNation PHP deployment. This was created for me by default, but this contains the truth of my application infrastructure. And if at any point in time, what's actually running does not match the truth in my deployment config, the system writes it for me. And the reason that this happened is because this replicas was set to 2, but when I killed it, the replicas actually running was only 1. And so OpenShift said, hey, Joker, what's going on? You only have 1 of these. You're supposed to have 2. I'm going to spin another one up for you, okay? Yeah. The application. Let me make sure I understand. You're asking, in order for this to work, the application and the configuration have to match?
Because I'm assuming that the Docker image includes the application and config.
It does not. The config lives outside of the image. It lives inside of an etcd database. You may not have heard about that, but it's a key value database created specifically for situations like this from CoreOS. And so that's what we're doing. And so we read these facts in on the etcd database, and anytime it mismatches. That's how we. Sure. I won't have time because I got to go to that book signing, which starts right after this. But I can talk with you after that. Yep. All right. What else you guys want to see? You want to see rsync real quick? I'll show you that. Okay. So we have this code running, right, that is on my local machine. Oh, I got to show you something else real cool, too. You can also scale down to 0 if you want. Why would you want to scale down to 0? I don't know. Yeah, maybe you're doing some maintenance or something. You can scale this down to 0 and then scale it back up to 1, whatever. So I scaled back up to 1. So now as a developer, like this is all cool, right? I was able to deploy my code as a Docker container, but man, if you tell a developer they got to wait 30 seconds every time they want to check something out, they're going to like murder you, like serial kill you even, right? That's a bad thing to do. Like they're not going to wait 30 seconds each time that they're going to build. So I'll show you something else we built in to alleviate this. Now this does work in the IDE as well as the command line, so I'm going to show you the command line first. So I have my code here, and I have a swap file. That's awesome. So I'm going to VI this in. I'm a mess today. I got to fix this machine. So let's add another line here, and just say rsync for the win, and I'll even spell it right. Maybe. Okay, so now I made this change, and so what we support is for you to actually rsync your changes in to the running container without having to run a new Docker build. Okay, so the way you do that is you do the command line. So you do oc get pods to get your pod ID, and then you do oc rsync your source directory, which is my current directory, to my remote directory, which is DevNation 2-WKI. Did I spell that right? DevNation PHP-2 WKI-Y6. And I just happen to know that it's opt app root /source. And so if I run that, it actually copied, what is Windows doing? It copied all my stuff over. So if I come over here and refresh the page, it's automatically updated, right? And so that was pretty cool. That only took a second. That did not commit to Git, and that's the problem. Well, it's not actually a problem. It's actually fine. So as a developer, when I'm developing stuff, I do something, I look at it, do something, look at it, and when it gets to some okay state, then I commit it to my local repository, work on other stuff, then commit it to the upstream. And so that's how I would work with this. I would do stuff, test it, rsync, and then commit it when I get something working. So it's not actually a problem. But this still kind of sucks, right? Because I got to, I got to make some changes in here, right? So maybe we'll paste this line, and then I got to run this rsync command, yada, 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 and then it eventually, that's still too much work for me. And so what you can do is actually, inside of Eclipse, and we're quickly running out of time, so I'm not going to show this, but you can set up on the properties for your project a builder. And this is not a PHP project. So Java, you don't actually have to worry about this because it's built into the JBoss Developer Studio 10. It'll just sync stuff over for you. It's freaking amazing. But for PHP, you would just create an external builder and just have it run that OC rsync command on save or on change. Then anytime you change something in a file, it's rsyncing in the background. And that is awesome for me as a Node.js developer, because it works the same with Node.js. Any interpreted language Compiled language is obviously not going to work, right? You can't rsync a Java file in, and you got to compile it and then move it over. That's why I use the integrated server synchronization inside of the new JBoss Developer Studio for development. Okay, the last thing I want to show you. What time is this supposed to end? Does it go an hour, or am I over time? Okay. Yes, question, sir. I couldn't hear you, sorry.
It only works if you're using source, not binary.
The rsync stuff?
Yeah.
Oh, yeah. So if you were using binary, the way you would do it is if this was a jar file, let's say I had a jar file here, test.jar. The way I would do this is I would just do OC start, OC new build, and then from file equals test.jar. And that'll hot deploy that jar file, or not jar file, war file out for me, or ear file, okay? But you would use, if you're doing Java development, I would really, unless you just hate Eclipse, I would look at the tooling that the JBoss team has developed for it. It makes it much easier and nicer to use. If you're an IntelliJ user, they are working on OpenShift 3 integration, but in the interim, you'd probably have to do the binary deployment.
Yeah. Typically, you have a CI build environment like Jenkins.
Oh, okay. Yeah, so we do have Jenkins plugins. You can just hook it straight in, and it'll just work for you. Yeah. We're actually doing a lot of stuff with pipelines and stuff that if you want to see the Jenkins work, go to the roadmap session today at 3. They're actually going to show, and I was going to show it, but I ran out of time. The web UI, all of this has changed to where you'll actually see your build pipelines across here with your different environments in the pipelines tab, and it hooks directly into Jenkins for that. We've done a ton of work around that stuff. Pardon? I am not. I don't have time. But the other thing I want to show you. Hang on. If I go into my pods here, in the web UI, I can actually open up a terminal. Did I show you guys that? Inside of the web browser. This is nice if I'm on Windows and I wanted to do something real quick, like vi-index.php, right? And so you can actually look at stuff on your pod inside of the browser. You can look at your event stream to see everything that's going on. And then you can also look at your quotas. So this is an environment with a quota. And so this tells me what me as a user I have access to. And this is determined by the sysadmins, whatever resources they have available for you. This is the exact same as Enterprise. They're all the same. Yeah, they're all the same. Yeah. What was new in 3.2? Persistent storage. So if I go into browse storage, I can add persistent volume claims, and I don't have any set up for this right now. But the way persistent storage works is Docker containers are traditionally stateless, meaning that if they go down, and when they come up, they come back, and everything that was in them is lost, right? Unless you do host-mounted volumes into it, but that doesn't work really well for multi-tenant environments because you don't want to mount host disk inside of a container. And so this comes to be a problem when you're doing things like, I don't know, a database, right? You don't want your MySQL database to scale up and not have the data available. So we invested a ton of work into supporting both stateful and stateless applications. And so the way it works is your administrator will set some amount of storage, whether that's from NFS, Gluster, Ceph, whatever, to you. And then as a developer, you make what's called a claim on this persistent storage. So I could claim 5 gigs of persistent storage. And I would, if it was set up in this environment, I would just add it here, and it would attach that same persistent storage volume to each of my pods. So all of the containers I have running has access to that data. And then if I was writing a Java application that maybe allowed users to upload images, I would then store those images on the disk on that persistent volume. mount point that I determine. I get to choose it myself, or I would set the database to use it. And we do have database templates. If I go to add to project, we have a lot of this stuff set up for you, so it's a little bit easier. Let's say I was doing MongoDB. So we have a MongoDB persistent one already. You just deploy it, and we have MySQL and all the stuff as well. So actually save your state across things. Oh, I did want to show you how to do Docker real quick, straight Docker. If I do OC new app and I just say Kubernetes guestbook, Kubernetes is the Docker username and guestbook is their repo. I could do anything here. I just know this one off the top of my head. This is actually going to search OpenShift and say, hey, I don't know this guestbook thing. I'm going to check out Docker Hub and see. And then it's going to go out to Docker Hub, pull that image from Docker Hub and deploy it. And so just to follow up on what I said earlier, you can run any Docker image on this thing. You just deploy it, right? And same syntax as normal. So if I go back into my console here, I should see a Kubernetes guestbook application. That's pretty quick. Well, okay. And so if I click it, oh, okay. So I don't have a route for it. So that's the big difference. When you deploy something from source code, we are able to create that route for you automatically because we know what ports it is. But if you're doing something from Docker Hub, it creates the service, but it doesn't expose the route. So I can't actually get to this right now until I click on Create Route, and then I can give it a host name if I had my own host name, like grantisawesome.com. Click on Create, and now I can actually hit the Kubernetes guestbook application that was pulled from Docker Hub. And you can do like Tomcat or whatever, All right, so I'm out of time, and I got to run to my book signing. But one last thing, the surveys, fill them out. Let me tell you how to fill this out. It's 5 stars. This is the only option. No, I'm just kidding. All right, thanks, guys. I appreciate you coming. And if you want my book, come up and grab it.